Assalamu alaikum. Due to the current COVID-19 pandemic, all the JEE aspirants are stuck in their homes. I have started this online lecture series to help all those students. I hope that they will find it very useful. Stay home, stay safe. Assalamu alaikum wa rahmatullah. In today's lecture, we will be discussing resistances in parallel. So, two resistances are said to be in parallel if across both the resistors the potential difference is same. With this word same, what we mean is the magnitude should be same, means equal, plus it should be the same potential difference across both the resistances. Let's take up an example and see what we mean by the same potential difference. For example, we have two resistances, or rather three resistances we have. We have R1, R2 and R3. If we discuss about R1 and R2, these two resistances are in series, that we have already discussed. Why they are in series? Because whatever the amount of current that will flow through R1, the same will flow through R2. And we have to make sure there is no, you can say, source or sink in between these two resistances. So these are said to be in series. The current is same. The same current flows through both the resistance. But what about the parallel resistances? For example, if I apply some potential difference across this system of resistors, if the potential difference at this is B and this is A, so this is VA and this is VB. Potential at this point is B, potential at this point is VA. The potential difference will be VA minus VB. This is the potential difference across that we are applying across the system. Now, if we discuss individual resistances, if we see R3, the potential across R3 or the potential that we are applying across this resistor, the potential difference between these 2 points, the two ends of the R3, this will be simply VA and VB, and potential difference across R3 will be VA minus VB. That's case number 1. Now, if we discuss the potential difference across these two resistances, the potential across this will be, for example, V1, potential across this will be like V2, but across this whole is VA minus VB. So this is VB, this is VA. Now, we have got the potential differences across all the three resistances. Across R3, it is VA minus VB. Across R1, it is V1 and it is not VA minus VB. Across R2, it is V2 and it is not VA minus VB. But we know the potential difference across a combination of these two, R1 and R2 taken together, means R1 plus R2, both the resistances. The potential difference is VA minus VB. Now, see from this, potential difference across with this R1 is V1, R2 is V2. So these two can never be in parallel. Let's not, you can say, only consider the physical configuration of these two resistances. Rather, we are discussing the potentials and the value of potentials and the similarity and dissimilarity between the potentials that we are applying across two different resistors. So R1 and R2 can never be in parallel. Why? Because V1 it's not the same as V2. Now this R3, the potential differences across this is VA minus VB. Across R1 plus R2, it is VA minus VB. See, these two are similar. I'm not, you can say, saying that this value is only equal, but it has to be similar. The same value has to be here. So it is VA minus VB. This is again same VA minus VB. So these two are in parallel. So I can say R3 is in parallel with R1 plus R2. R3 is not in parallel with R1. So these two are not in parallel because the potential difference across this is V1 and it is not VA minus VB, but across this it is VA minus VB. R3 is not in parallel with R2. So this is the simple basic, you can say, way how we can recognize if two resistors are in series or in parallel. So we will take up a couple of more examples so that we understand this concept very well. Let's take up one more example. For example, this question. So R1 is in series with R2. R3 is in series with R4. That's obvious. We know it. But now what about the parallel? Is R1 parallel with R3? So we have to see the potentials. For example, the potential of this point is A. The potential of this point is B. The potential of this point we don't know. And this is B. The potential of this we don't know. But one thing is for sure, in most of the cases, these two potentials will not be same. They might be, we can say, equal. In that case, the circuit, we can redraw it in a different way. But right now, this potential difference is not same as this potential difference. Why? Potential across this, for example, if this is X and this is Y, the potential difference across this is A minus X. Potential difference across this is A minus Y. This is not same. Point X and point Y, they are two distinct points. So R1 is not in parallel with R3. Simple. Likewise, R1 cannot be in parallel with R4. We cannot say it is in parallel with R4. Why? The potential difference across R4 is Y minus B. Potential difference across R1 is A minus X. They are very different potentials. Likewise, R2 and R4, R2 and R3. So among all these, R1, R2 are in series, R3, R4 are in series, and no two resistances are in parallel. That's the thing. Now let's change a bit, you can say, this circuit. Let's add one more limb to the circuit. For example, what if I add, now this is the second part. What if I add one more limb like this? The moment I added this is simple conductor. What the conductor does, it will equalize the potentials. So X will be equal to Y. So these potentials will be same. Not only equal in magnitude, rather these points will get merged. So they are the same points now, X and Y. These are the same. Now let's again try to analyze the circuit. Now the current flowing through R1, whether it will go through R2 or not, we don't know, because now we have a limb here. And we will do some questions on this, because in JEE we have to calculate the current through conductors within the circuit. So that is a bit, you can say, complicated, but we will try it later on. Right now what we can see is the current flowing through R1. We are not sure whether the same amount will flow through this. Why? Because some, you can say, current, a part of the current might flow through this conductor like this. So these currents will not be same. Means R1 is not in series with R2. They are not in series. Likewise, R3 is not in series with R4. What about the parallel? The potential difference across this is A minus X. The potential difference across R3, it is A minus Y. Since X equal to Y, since these 2 points are now the same, so we can say the potential difference across this is A minus Y, this is A minus Y. Or we can say this is A minus X, this is A minus X. Because these 2 points are at the same potential. Not only the equal potential, but same potential. So these two are now in parallel. So R1 is parallel with R3. Likewise these two. Because since these 2 points are the same, B is common for again both these resistances. The potential difference across both will be same. So I can say R2 will be parallel with R4. About series, we don't know. They will only be in series if current through this limb is 0. If 0 current flows through this limb, it means whole of the current will flowing through R1, that will flow through R2. In that case, they will be in series. Is there any condition that despite this limb, we will have 0 current through this? Yes. We have balanced conditions that we will be discussing in coming lectures. But right now, the simple question is we have to identify whether 2 resistances are in parallel or not. You can just pause the video and note it down. We have one more case. For example, this is 5 ohm, this is 2 ohm. This is 5 ohm, this is 2 ohm. 5 and 2 are in series. 5 and 2 are in series. What about 5 and 5? Let's suppose we are applying some voltage. I will not be adding the battery. Let's apply some voltage. This is 0 volt. This is 10 volt. Or rather, this is 14 volt. 14 volt. So the potential difference across these 2 points is, this is 0, this is 14. Potential difference is 14 volt. What is the net resistance between these 2 points? It is 5 plus 2 in series, that is 7. So the current will be 2 ampere. So this will be 2 ampere through this circuit. Again, the potential difference across this part, because since this is 0, this is 0, this is 0. This is 14 means this is 14, this is 14. The potential difference across this is 14 minus 0, 14 volt. Net resistance is 7. 14 over 7 is 2 ampere current. From higher potential to lower. Likewise, in this part of the circuit, higher potential to lower potential, current value will be 2 ampere. Now let's analyze the voltage, can say, or the potentials at different points. The potential at this point is 14 volt. Since current is flowing from left to right, there will be a drop. I can denote it like this, plus minus, in the direction of current. So there will be drop. How much drop will be there? 5 into 2 IR, that is 10 volt. 14 volt, 10 volt drop. So the remaining, that is 4 volts. The voltage at this point will be 4 volt. Now the current, how much current is flowing through this part of the circuit? 2 ampere. Now there will be again a drop. So this is plus, this is minus. How much drop? Resistance R into I, that is 2. 2 2s are 4. So 4 volt. So the potential at this point is 4 volt. There will be a drop of 4 volt. The remaining, that is 0 volt. It has to match this R convention. So this is the 0 volt. 4 minus 4, it's again 0. Fine. Now let's analyze this part. Again the same, 14 volt. Again the drop plus minus. This will be 10 volt drop. After drop, this voltage will be 4 volt. Again there will be a drop of like plus minus of 4 volt. The answer is 0 volt. Now why I am showing this example is because the voltage at this point is 4 volt. The voltage at this point is 4 volt. What is the potential difference across these 2 points? It is 14 minus 4. That is 14 minus 4, that is 10 volt. Potential difference across 5 ohm. What is the potential across this 5 ohm? It is again the same. 14 minus 4, that is 10 volt. The potential at left side of both these, it is 14 volt. The potential at the right side is 4. So the magnitude is same. But actually these 2 points are not the same. They are 2 different points. So while analyzing these different circuits, we will not treat these two to be in parallel. That is the question. Because these values are equal, but these potentials, the value of the potentials, this and this, it is same, 4 volt, 4 volt. It is equal, but it is not the same. This 4 volt is some different case, this 4 volt is some different. Fine. We will again analyze this. For example, we have a resistor R and the potential, this R is in US and the potential difference across this is 10 volt, this is 0 volt. Potential difference is 10 volt. Fine. Now we have the same R. Maybe it's one more R we have. This is in UK. And the potential difference across this is 10 volt, it is 0 volt. Fine. The potential difference across these two is same, 10 volt. The potential difference here is 10 volts, the potential difference here is 10 volts. But these potential differences are not the same. So we cannot say that this resistor in US is in parallel with this resistor in UK. That's not the case. So in a technical way, both the resistances, they have to be a part of the same circuit. Otherwise, we cannot have two resistances in parallel. Even if the potential difference across those, the potential difference is equal. So this word, the potential difference across the two resistors should be same, means both have to be a part of the same circuit. Then they are said to be in parallel. Now let's move on how to analyze the circuit when different resistances are in parallel. For example, we have some current flowing through this, I current is flowing through this, and we have different resistors. For example, we have R1, then we have R2, then we have R3, likewise. And we are connecting this to a battery where potential difference is V. Now if we see the potential difference, this battery we are applying, the potential difference is V. It means if we consider the 0, this is V, this is 0, 0, 0, 0, and this is V, V, V. Now this V, 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 this is the same V. It is not only about the magnitude, rather all these points are connected to the same point V. Likewise these 0, 0, 0. So all these three resistances are the part of the same circuit. And the potential difference across all three, that is same. V on one side, 0 on the other side, potential difference is V. Since that is the case, R1, R2, R3 are said to be in parallel. What if we have one more resistance like this, R4? In that case, these two will be parallel and these two will be in parallel with combination of this, R1 and R4. Because the potential difference V and 0 we are applying across the combination of R1 and R4. But right now we don't have this, so let's omit this part. So these three resistances are in parallel. What we can see from this figure is if there is some current flowing I through the circuit like this, it will get divided into three parts. So this is I1, this is I2, this is I3. And from this we can write simply this I will be equal to I1 plus I2 plus I3. We can say this is the conservation of charge or the basic law that we use in current electricity. So this current will get divided in three pieces. We will not lose any charge, we will not gain any charge while we are distributing this current. So if this I is equal to I1 plus I2 plus I3, this I is the net current. So I can say the net current from the Ohm's law, if I just club it, all these components, and I consider the net resistance of this is R net, that is the net resistance of this whole circuit. Fine. If the net resistance of this whole circuit is R net, then this current will be equal to potential difference applied divided by R net. Fine. Now this is equal to I1. What will be the value of this I1? We are applying potential difference V across resistance R1. Again, Ohm's law. So Ohm's law says I is directly proportional to V, or I is equal to V by R. So this I1 current through this will be V over R1 plus I2 current. I2 current will be again V over R2 plus I3 V over R3. Why we are writing the same V here? Because the potential across all these three resistances, that is the same, V. Now V, we just cancel it out. So we are left with 1 by R net equal to 1 by R1 plus 1 by R2 plus 1 by R3. If we have n number of such resistances, we will extend the same. So we can write 1 by R net equal to 1 by R1 plus 1 by R2 plus so on up to infinite, maybe n number. So this is the simple, you can say, resistances in the you can say parallel, the net value of the resistance. This part is very simple. Now you can say do simple questions. You can just try few questions on this. What if the value of these resistances is same? The same resistance is repeating itself, maybe R. In that case, we will get 1 by R net is equal to maybe 1, 2, 3, 4, 5, 6, 7 up to n. So we will get n by R if we have the same resistances. In that case, R net will be equal to R by n. If we have two resistances R and R, the net resistance will be R by n. N is there 2, so the net resistance will be R by 2. If we have 1000 resistances R in parallel, the net resistance will be R by 1000. Simple. This is the simple addition actually. In this, we can have some series, you can say exponential series or 2 factorial that we have discussed, I think, or LN series. LN series again important. At times they ask these questions. And LN series we have discussed in electrostatics. So this is now simply the question of, you can say, the basic mathematics. We will not be discussing those things. We have discussed those things, especially the LN series or the exponential series and other series. So we can get the answers from this. This is simple. Let's discuss the distribution of these currents. For example, current I gets distributed in R1 and R2. Are these in series or parallel? They are in parallel. Very simple. These two resistances are in parallel. So if this gets divided into two currents, so this is I1, this is I2, I can say this I1 is equal to V by R1 that we discussed, because if the potential difference across these two is V, let's suppose this is V, this is 0, V 0. These are the same points. Now this I2 will be equal to V by R2. If we have so many, you can say, resistance in parallel, we can say I3 is equal to V by R3, I4 is equal to V by R4, and likewise. What will be the ratio of these two? So I can get I1 is to I2. That will be equal to V by R1 is to V by R2. This is the simple ratio bit of 2. So VV gets cancelled. So we will get 1 by R1 is to 1 by R2. In series, what we did, V1 is to V2 was equal to R1 is to R2, likewise. But here I1 is to I2, because I1 here varies. The V across both resistance is the same. I1 is to I2 will be equal to 1 by R1 is to 1 by R2. What does this relation signify actually? If we can say, see it very closely, if the resistance R1 is very higher, so it means this path will be providing more resistance to the current. So more current will flow through R2. If in between these two resistances, R2 is very high, it means this R2 will be providing more resistance to the current. So the more current would prefer to flow through R1. If these resistances are equal, it means current will get distributed equally among these two resistances. What if this value is very, very less than this, or rather this tends to 0? That we will discuss again. If R1 and R2 is equal to, if they are same, for example, R1 is equal to R2, if they're same resistances, this distribution I1 is to I2 will be equal to 1 is to 1. It means current will equally get distributed among two ways, two paths. Let's discuss this thing. What if R1 tends to infinite? It means this resistance tends to infinite, means the R1 resistance is providing infinite resistance to the current. So the current will simply prefer the other path. So if R1 is infinite, the current through this R1 will tend to 0. This is very important. Then whole of the current will flow through R2. So current through R2 will be equal to I, actually total current through R2. Current will prefer to flow through the resistor that provides, or that resists the least. What if R1 tends to 0? It means 0 means it is providing least resistance. This is the least resistance possible. And if R1 tends to 0, it means it is almost like a conductor. It is not a resistor. It is a pure conductor. Although every conductor has some resistance, but this resistor, when we say R1 tends to 0, it means it is a pure conductor. It is not showing any resistance to the flow of the charge. So if R1 tends to 0, what does it mean? It means all the current will flow through R1 and current through R2 will be equal to 0. So it is a simple logic. If between these two, or even if we have thousands of such resistances, if any one of the resistance is 0, all the current will flow through that. Because current prefers the least resistance path. So if we have a 0 resistance path, it will flow through that. Simple. If we have one of the resistances is infinite, so current will not flow through that infinite path. It is very simple. The current will follow the other paths, whatever is available. If we have only one path, it will flow through this. If we have 1,000 paths, it will get distributed as per this ratio. That is a simple thing. So this we have to understand. And this R1 tends to infinite. It means actually a kind of an open circuit, what we call it. That we will discuss later on in this chapter. And if this R1 tends to 0, this is kind of a short circuit, or we say this is a pure maybe conductor. The potential at this and at this point, these 2 points get connected through a conductor which has a resistance of 0 ohm. I think this part is clear. So we can move to the last topic of this resistances in parallel. Now this is a kind of a distribution. We have a different, I have already recorded a separate lecture on this distribution of the currents within the series and the parallel combination of these resistances. But right now, let's try to find out how to detect these resistances in parallel and other stuff. For example, we have a circuit like this. This is again any value. This is X volt battery. So we have three resistances R1, R2, R3. So are these R1, R2, R3 in series or in parallel? That we have discussed. So if the potential we are applying, the potential difference we are applying, why this battery is X, it means if this is 0, this will be X. Now see what is happening. So if you would say that this potential, for example, this is A and this is B, this is B, this is B. Potential difference across R3 is AB, A minus B. Across R2 is A minus B. Across R1 is A minus B. Why? Since this B point and this B point, they are connected by a conductor, they are the same, you can say, they are at same potentials. Not only equal, but same potential. These 2 points are the same. Again, this is connected to this point, so again the same. So what will happen? When the current flows, it will flow like this. Then we have different paths. Now a student would say that looking at this picture, R1, R2, R3 are in parallel. Why? Because the potential difference across this is A minus B, across this is A minus B, across this is A minus B. The same potential across all three resistances, they are in parallel. But what if we apply the potential difference across these 2 points? Now see, the current will flow like this, I. Now I has got different paths, this and this. Now the current has different paths. So current has, for example, current can get distributed like this and this. Now see, from here current has to flow through resistance R1, R2 or maybe R3, but from here there is no resistance. Again from here to here, no resistance, back. So current will flow like this. So this will act like a bypass. So this will bypass whole of the circuit. So these three are not in parallel, neither series. They are just there, out of the circuit. They are not even a part of the circuit. Even if we can say connect these resistances or disconnect them, it will hardly matter in this case. What about this? R1, R2, R3, which are in series, which are in parallel. So current will flow through this and this, they are at the same potential. They are at actually the same points. So if this is A, this is also A. If this is A, this is also A. Now we can say if this is V, 0 volt, this is V volt. If this is V, this is V. This is also V. If this is V, this we can say this is V. If this is V, this is also V. Now see, V and 0 and V and 0. So R2, R3 are in parallel. So R2 is in parallel with R3. But what about the R1? Like, to be very frank, R1 is not even a part of the circuit. Why? The current will flow like this. Current has got a, you can say, a zero resistance path here. So all of the current will flow through this path, then get distributed like this. That's why the potential at this and this point is the same V. And potential difference across R1 is V minus V, that is 0. So this is not there. We don't need this. Current will directly flow like this. So this circuit will behave like this. R2, R3, V, 0, like this. Now likewise, we have to analyze circuits and we have to see whether different resistances are in series or parallel. It is not all about the physical, you can say, configuration of the circuit. For example, these seem to be in parallel, or maybe different resistances seem to be in series. For example, these two resistors seem to be in series, but actually since there is this branch of the circuit, these are not in series. So it's not all about what we see in the physical circuits, rather we have to see the current values. If same current is flowing to different resistances, they are in series. If same potential we are applying across different resistances, same potential, then those resistances are said to be in parallel. Hope you understood this concept. Now we can apply this anywhere, and we can maybe try a couple of questions from HC Verma. We have a few good questions given there in the exercise part. See you soon.